Hello Year 7 and Year 8 and welcome to the final week of the remote learning. So this week we're going to be learning about reactions and it's the first of 2 lessons. So as per usual you need to refer to your fact book. So this week's lesson on reactions is found in your fact book and should be under week 5 lesson 1. The 5 facts that you need to be able to learn for this lesson, and hopefully you've been looking at them from last lesson, is what an element is, what a compound is, what the periodic table is split into, and some properties of metals and non-metals. So like we have previously for the past few weeks now, we're going to start with a starter. So there's 4 questions. What is it called when you change from a liquid into a gas? What is the formula to calculate speed? What are the 4 functions of the skeleton? And define an element. So it's not just based on last week's information, it's based on previous weeks as well to make sure that you're still recapping those facts. So I'll give you a few minutes to do those and then we'll go through them. Okay, so let's go through those then. So what is it called when you change from a liquid into a gas? It's evaporation. So the particles are moving quicker, so they're changing into a different state of matter. What is the formula to calculate speed? It's speed equals distance divided by time. If you've just done S equals D divided by T, that's fine. What are the 4 functions of the skeleton? They are movement, they make red blood cells, it supports and it protects. And define an element is made up of one type of atom. Now don't worry too much if you didn't get the last one, because that's something we'll be going over in this lesson. The other 3 things are information that we have previously been over, so it's stuff that you should already know. So what can you remember about elements? So in front of you, you've got all the elements are found on the periodic table. You'll find that the symbols for the names of things, sometimes they don't necessarily have the same letter. So for example, you've got some over here. So you've got on your right, you've got your non-metals, on your left you've got your metals. So things like sodium, that's got the symbol Na, but it begins with an S, so don't get too confused with that one. So what I want you to do is you can keep flicking back to the previous one with the periodic table on. What I'd like you to do is find the element name and the chemical symbol. So the first one, the element name is hydrogen. You'd need to look it up on the periodic table and see what the chemical symbol is. For the second one, you've been given the chemical symbol, so you need to find out the element name. So I'll give you a few minutes to do that, and then we'll go through them. Okay, so let's have a quick look then, and let's see how many you managed to get right. So, first one, hydrogen, you should have had H. For O is oxygen, nitrogen is N, C is carbon, zinc is Zn, remembering that it's a capital letter first, then lowercase. Then you've got copper as Cu, S is sulfur, aluminium is Al, I is iodine, bromine is Br, chlorine is Cl, sodium is Na, potassium is K, and magnesium Mg. So hopefully you managed to get majority of those by using the periodic table. It's something that you need to be able to do. So hopefully you've done pretty well. So just a bit of background information about what an element is. Some of you might already remember this, some of you might not, so it's just a bit of a refresher. An element is a substance that can't be broken down into smaller substances. So that's the smallest thing that can exist. It's like an atom is the smallest thing that can exist, but atoms make up elements. So an element is made up of one type of atom. So gold is only made up of gold atoms, carbon is only made up of carbon atoms, and elements are found on the periodic table. And it's something that we have learnt about before, and you've just shown that you can find elements on the periodic table. So a compound is a pure substance that's made from 2 or more elements chemically bonded together. Now it's really important when you're asked to define what a compound is that you say that it's chemically bonded together. If you don't say that and you just say they're joined together, it doesn't mean the same thing. So make sure you say that really key word, chemically bonded. So salt is an example, and that's made from sodium and chlorine. That's the salt that you would put on your fish and chips, on your meals. It is the same salt. So that is an example of a compound. So, splitting the periodic table into metals and non-metals, you'll see that zigzaggy line on that picture in front of you. So this periodic table, it doesn't include every single element. I've just taken a screenshot and just to show you how metals and non-metals are split. So you can see that on the right you've got your non-metals and on the left you've got your metals. It's just one way of sorting it out and classifying the periodic table. So make sure you know which side is which. So the next thing that we're going to do is look at properties of metals and non-metals. Now in front of you you've got a list or some key properties of metals and non-metals. What I want you to do is make a table with 2 columns in, 1 metals, 1 non-metals, or just make a list and then put them into the correct column for me, please. So I'll give you a few minutes to do that and then we'll go through it. Okay, so let's have a quick look then. So what you should have had is a table that looks similar to this. So you've got properties of a typical metal and properties of a typical non-metal. So metals are usually good conductors of electricity and heat. They are shiny. So if you look at any metal, you can probably see some around you now. It's typically shiny. High density, meaning that it's quite heavy. So if you lift up a piece of metal, typically it's quite heavy. I know if you pick up jewellery, it's not going to be. But if it's found in a big clump or a big large mass of it, it is going to feel quite heavy. Malleable, so it can be hammered into different shapes, so that's why it's used for jewellery. Ductile, so you can pull it into wires, so it's used in wires as copper. Sonorous, so if you hit something that's metal, it'll make a ringing sound. Non-metals are usually the opposite to your metals, so they're poor conductors of electricity and heat, so things like oxygen and boron on the right hand side of that periodic table. They're dull, so they're not shiny to look at. Low density, so it's light for its size. It breaks very easily and it's not sonorous, so if you hit it, it'll typically break, it won't make a ringing sound. Most metals also have high melting points and they're usually solid at 20 degrees C. Many non-metals though have low boiling points, so that's why they're typically gases at room temperature. Okay, so that is everything that you needed to know for week 1, and hopefully with those activities you've started to see that you've started to remember some of the information that you need to remember. Now don't forget to keep going over that and keep revisiting things to make sure that it's fresh in your memories. For the next weeks we're going to be looking at something slightly different, so we're going to be looking at acids and alkalis. So the facts that you will need to know for week 5 lesson 2 on reactions are found in your fact book, but they're also here in front of you now. So the pH scale shows an acid, alkali and neutral substances by colour. There's 3 main acids and they are hydrochloric, sulphuric and nitric acid. They're the ones that you would use in a school laboratory. An example of an alkali is sodium hydroxide. And when you mix an acid and an alkali together, you make salt and water. So get learning those facts. Make sure you don't forget to keep recapping the previous facts, because you will be asked questions in the next lesson as well on those. Have a fun time learning, and I shall speak to you soon.